This video serves as a review for your test on trigonometry, or at least the second part of it. These questions generally follow the order that are on your worksheet. The first thing that you're going to need to be able to do is change to and from degrees and radians. So if we're changing to degrees, that means we have radians. And as we go from radians to degrees, we expect to get larger. So we do have a formula for this, and that is degrees, we're starting at radians, so radians times 180 over pi. 180 is on top because, again, we're expecting to get larger. So down here, here's my example. We have the 4 pi over 3, so we're going to multiply that by 180 over pi. And now we're going to have to do a little bit of cross-canceling. Now, look, it is times. This is not equal. This isn't a proportion. So we aren't going to cross-multiply, but we will cross-cancel. And we do see that the pi's cross-cancel. So the pi's go away, and the 3 will cancel with the 180. What I'm doing here is I'm dividing by 3 both of these. So 3 divided 3 is 1. So I'm left with 1 right here, and 180 divided by 3 is 60. So that leaves me with 4 times 60, and that gives me 240 degrees. And what we want to make sure that is that we do have this degree symbol there, because if we don't have that, that means we're talking about radians. So like right here, notice there wasn't a degree symbol, so if it's not there, we assume radians. To change to radians, we're actually going to do the opposite. So if we're going to radians, that means we're starting at degrees, and we expect to get smaller. So we just flip this ratio around, and we do our degrees times pi over 180. It's the same exact thing, basically. So here's my example, 80, and notice I do have degrees right there, so times pi over 180. And now I'm going to do a series of cross-canceling. So first of all, that'll be over 1. I see that both of these are divisible by 10, so I'll do that first. So I'll divide those both by 10. I get 8, and I get 18. And now I compare the 8 and the 18, and I see that I could divide those both by 2. So I'll go ahead and do that. Divide by 2, divide by 2. And now 4 and 9 have no common factors, so I can't cross-cancel them any further. So top times top, 4 pi, and bottom times bottom, 9. So this is 80 degrees in radians. The next thing we need to be able to do is when we are given a trigonomic function, you also have pictures, and you'll have to find the midline, the amplitude, and the period. So let's just kind of quickly go over that. So if we have our wave, our midline is going to be the middle of that. So in this case, that's right here. And our amplitude is our height, and it should be the same if I measure it here or if I measure it down here. The amplitude should be the same. And the period is going to be this distance right here. And it should be the same for every single cycle of the wave. That's if I have a picture, but we do have a formula. And our general rule here, and I'll put it down here, is we have 3 trigonomic functions that we're talking about. We have sine, cosine, and tangent. And if I'm talking about wavelength or period, so I like to use lambda to mean wavelength, our period. So our wavelength for sine always starts at 2 pi. That's this distance. And for cosine, it starts at 2 pi. And for tangent, it's half of that. It's pi. And what we did is we had this basic form, and I'll just do it with sine, where we have a sine, then we had bx minus h plus k. This was our basic form for our trig functions. It doesn't matter if I have sine, cosine, or tangent right here. This a was our amplitude, the exception being tangent. Tangent, it doesn't make sense to talk about amplitude because it's infinite. It goes infinitely tall. B had to do with our cycles, We'll talk about how we're going to use that in a second. And then our H and K are related to our shift. So our K is actually our midline, and our H is related to our shift. So I didn't write shift up here, but you may be asked that. So how am I going to get the midline? So in this example, this 2 is my midline. So my midline, I would write midline is y equals 2. For my amplitude, that's this number. So my amplitude is 3. Now getting my period is going to be a little bit trickier. So my period is going to follow a formula that involves this right here, my B. And that formula is our period is our starting wavelength, so in this case 2 pi, divided by B. So in this case, I have a 5 right here, so I'm going to do 2 pi all over B, that's the 5, so 2 pi over 5 is my period. If I were asked for my shift, we need to remember what do we need to have right here in front of x? We need to have a 1, which means I'm going to actually divide all these numbers inside of here by that number. So our shift, I'm going to take that and divide it by 5. And since this is minus, it actually goes the opposite direction. So it's going to not go left, but it's going to go right. And not pi over 3 because I have to divide by this 5. So there's a 1 there. It's going to be right pi over 15. So you may not remember. So if I had pi over 3 and I'm dividing that by 5 to get this shift, flip this around, so 1 over 5, and change this to multiplication, and top times top, bottom times bottom. So I get my pi over 15 there. All right, let's try this one. So our midline is going to be y equals this number, so -3. My amplitude is going to be this number, but remember amplitude should always be positive, so it is 2. Our period is going to be lambda is 2 pi over b. This is our b, so 1/4. So it's going to be 2 pi over 1/4. Now we can put this in our calculator if we want, and we would type 2 divided by, because this fraction bar means to divide, parentheses 1 divided by 4. In any event, our calculator is going to pop out 8. And I need to remember that I have a pi right here. So 8 pi. So that's our period, and that leaves our shift. So this is getting a little bit messy right here, but our shift, there's a way to get our shift really quick. So our shift is going to be our h divided by our b. So our h in this case is pi over 2, and I'm going to divide that by b, so 1/4. And that's going to end up being, so I'd keep this means to divide, so it's really division. So I'm really doing pi over 2 divided by 1/4, and keep flip change again, and I'll get 2 pi is my shift. So there is one other thing that we might want to do for this. I'll come back to it at the end though. Okay, so find exact. Well, find exact what? So if I have sine of 0, sine of 30, sine of 45, sine of 60, or sine of 90, I need to be able to write these in exact terms. If I type in my calculator, I'll get decimals. So you can either memorize this. We also need to do it with cosine for each of them. And we also need to have it memorized for tangent for each of them. So this is actually going to be a lot, and I think it's actually easier to kind of cheat on it and use the calculator to help us. And instead of memorizing all these, what I would do is I would memorize the fractions. So a half is one of the ones that comes up, and that's 0.5. Root 3 over 2, that comes up a lot, that's 0.866. Root 2 over 2, that's 0.707. The other one that comes up a lot is the square root of 3, but I actually forget that one, so I have to put it in the calculator. And that one is going to be 1.73. So square root 3. That's 1.73. And we also need to do root 3 divided by 3. And that one's going to be 0.577. So whenever we're doing this, we need to make sure that we know which mode we're in. So if I put degrees symbols right here, I mean these are all in degrees, and the sign of 0 is going to be 0. The sign of 30 is going to be a half. The sign of 45 is root 2 over 2. The sign of 60 is root 3 over 2. And the sign of 90 is 1. So you need to be able to, if I give you any of these in degree or radian mode, to be able to give them to me. So I'll do cosine now in radian mode. So it would be 0, pi over 6, pi over 4, pi over 3, pi over 2. So the cosine of 0 is actually 1. The cosine of pi over 6 is going to be root 3 over 2. The cosine of pi over 4 is root 2 over 2. The cosine of pi over 3, that is a half. And the cosine of pi over 2 is 0. Now, if I want to do tangent, and again, I'll just do it in radian mode. That's usually the mode that you would be in on your Regents exam anyway. So the tangent of 0, well, what is that going to be? That is actually going to be 0. The tangent of 30 is going to be root 3 over 3. And you might be wondering, as I did all this, how did I know this? I'm actually just typing it in the calculator, and I'm recognizing each of these decimals. And I associate the decimals with their exact representation using the fractions. Tangent of pi over 4, that's 1. Tangent of pi over 3, that's root 3. And the tangent of pi over 2, that's going to give us an undefined or a domain error. The reason for that is because tangent is actually the ratio of the sine of our angle divided by the cosine of our angle. And since the cosine of our angle at 90 or at pi over 2 is 0, I can't divide by 0, and that's why we get this undefined. And when we're graphing with tangent, we get this dotted line right here, and that's called an asymptote, and that is where this is undefined. So you need to be able, you're going to have these on your test randomly, like I might select this one, and this one, and this one, and you would have to be able to put them in exact terms, not with the decimals. So if I give you this one on your test and you wrote 0.866, you're actually going to get that wrong because I'm looking for this exact number. We spend a lot of time on graphing, and I don't want to completely spend this whole video on graphing this, but we need to be able to do a table of values. So a few things that we determine when we're doing our table of values on our calculator and getting a bunch of points is, first of all, that we generally want to increment the x-axis by, now we're going to be in radian mode, sorry, that's really sloppy right there. We want to increment the x-axis by pi divided by 12, and that's about 15 degrees. So each hash mark is going to be 15 degrees. And what we're going to want to do from this is actually find our midline. So our midline's 1. And I'm incrementing this. So this first hash mark here is pi over 12. And I know that's going to be really small for you to see, which means the next hash mark is 2 pi over 12. And the next one, 3 pi over 12, and so on. And I'm not going to write all of those. I'm also going to want to know not only my midline, but my amplitude. So that tells my amplitude of 3 tells me that I'm going to need 3 of these. So 1, 2, 3, maybe even a 4. 1, 2, 3, 4. My midline's -1, so that's right here. So I want to make sure that I'm graphing off of this midline, not just the x-axis. All right, so it says 2 complete cycles in this example, but I might say 1 complete cycle or 3 complete cycles. That means I need 3 or 2 complete curves, in this case, 2 complete curves. All right, so I'm going to go ahead and set up. Now, you can get your calculator to do this. Remember, we go to Table, Set, and we want to make sure that our is called Delta Table, and we want to make sure we set that to pi over 12. And we also want to make sure that we are in radian mode. So make sure that your calculator is set to radians and not degrees. So I'm just going to pull up my table and make sure that I have put in. Now, when you put in this, you're going to have to tell it what to type. So you're going to press your Y equals key, and you're going to type all of this in. So I'm typing in 3 sine parentheses 2x minus 1. And I'm going to start my table. And there we go. Table. I'm going to table that. Okay, so at the first point, I get 0, -1. I'm not sure what color I should use here. Maybe blue. So 0, I got -1. There's the first point. And at the next one, I get a half. So if this is a 1, then halfway in between, that's a half. And at the next point, I get 1.59. So getting a little bit closer to 1 right here. Oh, 1.59. My bad. That would be halfway. So that should be like right there. And then the next one is 2. So like right there. And the next one, 0.59. 1.59. And the next one is 0.5. Right there. The next one is -1. Down here. The next one, I get -2.5. So this is -2. -2.5. It's going to be right here. The next one, -3.59. So that's going to be like right here. The next one is going to be -4. And I do see a pattern emerging, so rather than read it off the table, I'm just going to continue the pattern. Now it said 2 complete cycles. So right here is 1. And now I'm actually starting on the second one. And you can just read these off your table if you want, but once you see the pattern, and you got to remember what sine and cosine look like. They should look like these wave things. And want to make sure we get both above and below our midline. It's not essential that these be exact. So I have, let's see, 1, 2. I actually did too many. So I'll just draw, generally, do a better job connecting than I am. There's 1, and here is 2. It said 2 complete cycles, so I don't need these. Okay, that's 2 complete cycles. 1, 2. All right, my questions are being covered up. Most of the rest of this is stuff for the honors students. we did arc length, and we need to be able to find this length right here. And our arc length formula is theta times r. This is an actual physical length, so we aren't going to say 20 degrees right here. Although that arc is 20 degrees, that's not what we want. We want an actual physical length. So if our angle is in radians, then all I have to do is multiply it by my radius. So essentially, our formula, arc length, is radians times radius. That will give us the whole length. So I need to change the 20 degrees to radians. So 20 degrees times pi over 180 and that gives me pi over 9. So now I'm going to use my arc length formula, replace the angle with pi over 9, and my radius is 16. And we can go ahead and use the pi key on our calculator. I'm going to get 16 pi over 9, which is going to be about 5.59. I didn't give a unit here. Let's say it's inches. All right, the next one is also set up to find arc length. I want to know this physical length right here. So I need to change the 30 degrees to radians. I get 13 pi over 18. Now I'm going to use that in my arc length formula. So I'm going to put this in, 13 pi over 18, multiplied by the 24, my radius. Now I could try to trip you up and give you the diameter instead of the radius, in which case you would have to half that and do 12. But I didn't do that this time. So we're going to go ahead and substitute that all in, multiply by pi, and I'll use my pi key, and I get this is about 54.5. Again, we'll say inches are our unit. On this one, I'm doing a trick on you. This time I give you the arc length, and I'm asking for, well, what is the radius? So I'm going to write my arc length formula, substitute what I know in, so my arc length is 100. My theta still needs to change. 60 degrees is pi over 3, and my radius is x. I don't know what that is. I'll clear my fraction. I'll multiply by 3. Now I'll divide by pi. So I could write this as exactly 300 divided by pi, but I'll go ahead and take an estimate, and you can do the same on your test. And I get our radius is about 95.5 inches. All right, we also spent time solving trig equations, and we need to remember our 4 quadrants on our unit circle. We need to remember that cosine is positive in quadrant 1, sine is positive, and tangent is positive. And we can get tangent by remembering tangent is the ratio of sine over cosine. In quadrant 2, cosine is negative, sine is positive, tangent is negative, because a negative times a positive. In quadrant 3, all of them are negative except tangent. And in the last quadrant, or quadrant 4, cosine is positive, sine is negative, tangent is negative. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. And how I'm getting these is cosine is related to x values on the unit circle, sine is related to y values, and tangent is the ratio of y over x. So that's going to be useful for this. So if I'm solving this, I want to make sure I get all the answers. So first I subtract the 2. So I get negative 2, 5 sine x, divide by 5. And now I'm going to use an inverse. But before I do that, notice that it's saying that I am in quadrant, I'm negative, so I'm thinking, where could sine be negative? Well, sine is negative in quadrant 3 and quadrant 4. For your test, I'm okay that you do this in degree mode, although I will warn you, on your Regents exam, they often put even solving these in radian mode, so just make sure you're in the right mode for whatever you're being asked. So we're going to do inverse sine, and my calculator pops out about negative 24 degrees. It just so happens that negative 24 degrees is not a quadrant 3 or 4 angle. Well, I could measure it backwards. I mean, I could measure it this way, clockwise, but I want the reference angle. So I'm going to ignore the negative, say my reference angle is 24 degrees. Now, to get the actual angles, here's my quadrant 3 angle, here's my quadrant 4 angle, and I know the reference angle is 24, so I know both of those are 24. So if I want this angle, I'm going to do, first of all, for the quadrant 3 angle, 180 plus the 24 degrees. So that's going to be 204 degrees for the first one. And for my quadrant 3 angle, or quadrant 4 angle, I want this. And the best way to get that is going to be to do 360 minus the 24. And that's going to give us 336 degrees. Sometimes we have a few other steps. So see here, I'm going to have to factor first. And when I'm doing a whole factoring solution, I must have a 0 on the other side. So if there's not a 0 there, you need to get a 0 there. I look at these and I see that sine is something that I could factor out. So I factor out sine of x. Sine divided sine is not 0, it is 1. And this sine has also been factored out. And now I'm going to set these equal. So sine x equals 0. And 1 minus 3 cosine x, that equals 0. All right, so I'll deal with this one first. I'm thinking, where is sine 0? Well, sine are related to y values. So right here and right here is where the y values would be 0. So that's at 0 degrees and at 180 degrees. If you were on the Regents, you would say instead of 180, you'd change that to pi. But we can do this in degree mode. Subtract the 1 for this one. Divide by negative 3. So I get cosine equals a third. So cosine is positive. So where is cosine positive? Well, if cosine's x values, I should be in quadrant 1 and quadrant 4. So I'm thinking of a quadrant 1 and a quadrant 4 angle. So now I'm going to do my inverse cosine. So when I do inverse cosine of a third, I'm going to get about 71 degrees. So that's my reference angle. So for quadrant 1, that's going to be easy. Got it. But quadrant 4, we are down here. So I need this angle right here, which is going to be 360 minus the 71. And that gives us 289. So there's our answers. Now, not just those, also these. I have 4 answers for that one. And on the previous one, I had just 2 answers. All right, that's it. Good luck.